I need to get a beard like that. This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans, and add-on services like backups, node balancers, Longview, etc., VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 40 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/rubyrogues. Hey everybody, and welcome to another episode of the Ruby Rogues podcast. This week on our panel we have Dave Kimura.
He's muted.
His video froze.
Hey, everybody.
Eric Berry.
Hey.
I'm Charles Max Wood from devchat.tv. Just a quick shout out about Ruby Dev Summit coming up in October. We also have one of our speakers as one of our special guests today, and that is Marc-André Cournoyer, something like that.
Yes, exactly.
My French is very
thanks
rusty.
for having me. That's pretty good.
Now, I know that some of the newer folks to the community may not know who you are, and you were on the show a really long time ago. So do you want to just kind of give everybody a brief intro to who you are and what you've been up to these days?
Sure. Well, probably my most known work has been the TIN web server, which has been around for quite some time and still being used. So I still maintain it, but so that's probably like how the work that has been more popular. But I've also created a few other stuff. More specifically, there's a Tiny RB, which is my own Ruby implementation that I created. I also wrote a book that some I have heard about. It's called Create Your Own Programming Language. It's the book that helped create CoffeeScript and many other languages.
Nice.
And that's mostly it. I think I was an early adopter of Rack too, and I wrote the first Rack adapter for Rails and a bunch of the stuff around Rack, since TIN was the first web server to be based on Rack. So I think that's mostly it. And nowadays, I mostly teach courses, advanced courses to developers online.
Awesome. You've been doing those courses for a while too, haven't you?
Yes, I have a course called Owning Rails that has been going for 6 to 7 years now. So it's an advanced course about Rails. So it has been going well. It's because it's really focused. Really, it's an advanced course just for what we do. Actually, is we rebuild Rails from scratch during the old course. So we start from active record. We rebuild everything from action view to the controller, and also a few months ago, actually, I added action cable too. So it's a pretty fun course, and I think people enjoy it. It's really helpful if you want to master the framework really quickly.
Is it an online course or an in-person course?
So it used to be a live course that I would teach, like you would join. I used to use Adobe Connect. Like people would join a bit like we're doing here and would ask questions in the chat room. But now I converted it to pre-recorded videos, so people can just purchase the course and do it on their own pace. So there are exercises and a bunch of stuff to help you do that. But it's pre-recorded now.
That's incredible.
Yep. So the topic that we have you on to talk about and what you're going to be speaking out about at Ruby Dev Summit. I'm sorry, I can't even talk straight. I went to bed at 4 a.m. this morning, and I think I woke up at 7:30. So anyway, I'm not entirely coherent. Anyway,
I'm going to stop you there just for a sec, because I got to say, before we get too serious, I got to say, Mark, so everybody has a doppelganger, right? You are Merrick Christensen's doppelganger. From you look exactly
from what?
Merrick Christian, he's a developer on JS Jabber. You look exactly like him really? If he had a big gnarly beard. Am I right?
Thanks for the beard. Okay.
Yeah, he does look a bit like Merrick.
Okay, cool.
Merrick's a very handsome fellow.
Oh well, I'll take the compliment. Thank you.
Okay.
Yeah.
Anyway,
sorry, I had to throw that out there before. Good times.
So we have you on to talk about learning machine learning, and we did an episode on machine learning probably a month ago, but it was interesting to kind of come at it from the aspect of how do you learn it, and You also have a bit more experience with doing machine learning in Ruby, which Tyler really didn't have. So I'd like to just dive in. Assuming that people have listened to that episode and kind of get the basics of machine learning, do you want to just tell us a little bit about your experience with machine learning, and then we can talk about how you actually pick this stuff up?
Sure. Well, my experience, I've I can talk a bit more about this later, but the way that I learned it is by like coding several projects that interested me, and I tried like several times like to learn machine learning and failed all the time. And mainly, I think it was because all the courses that I found were really math heavy. I don't know if you guys have tried to go and watch like the Coursera course from Andrew Nung or NG. I always forget how to pronounce it, but it's a really popular online course to learn machine learning, but it's really math heavy. It was, at least for me. So it didn't work for me. I tried to like schedule myself to watch one of his videos each day. It's something like that, but it didn't really work. Until the day that I like read about a paper. I don't know if you guys have seen this. It was called or nicknamed like the Google chatbot paper. It was a bunch of researchers. They had made like a chatbot that was based on neural networks, and you would train the neural networks with movie dialogues. And at the end, what you would get as an output was just the chatbot could have a conversation. It was pretty amazing the kind of conversation it could carry with just training from the movie dialogues. Like, it was all coherent. It could follow a conversation with several sentences and all of that. So it really blew me away. And that was the driver for me. I told myself, oh, I'm going to recreate something like that, because it was as it's often the case with the research paper, they didn't publish the code, right? So there was nothing around that you could just execute and mimic the results. So I told myself that I would recode it and create it from scratch. So I did eventually manage to create it. It's actually, if you want to check it out, it's on github.com/MA my username there, and /neural convo for neural conversational model. That's kind of the name of the research paper from Google. And that's my re-implementation of the Google chatbot paper. It's not in Ruby, like you mentioned earlier, but this one is in Lua or Torch. Torch is the name of the framework used there. It's a popular framework for machine learning used at Facebook, Google some time ago, and DeepMind too use it, I think.
Oh, wow.
So I have a question just around the whole machine learning and stuff, because that really definitely seems to be like the wave of the future. Is there any kind of special like hardware? I mean, do you have to go out and buy like the top of the line hardware to just start toying around with this? Or are computers today pretty much fast enough to build proof of concepts and implementations, but then, when you actually go to deploy this to any kind of real production scene, are you going to have like an entire farm of servers just to handle like this neural processing? Or is it, really just a couple of servers and it just does its thing?
That's a good question. But there are two parts of machine learning. There's the training one, which requires lots and lots of power, right? And the like you mentioned, like the deploying one usually requires a bit less CPU power or GPU power, as I'm going to talk a bit maybe later. But like when you want to actually use the model that you've built with machine learning, it requires a bit less power. So that usually is not going to be the problem. The problem is with training, because you want to provide how machine learning works as you provide examples, lots and lots of examples, and you train it several times on the same example. So that requires lots. But the more power you have, the faster it's going to be. So to give you a concrete example with my, but actually, as your question was, can you do it with like everyday computer? Well, I started initially with my project Neural Convo with my iMac that I'm using currently using for this interview, and it worked pretty well. But the limit that I've reached is not really the power. It was the memory, because you want to fit like your model, you want to train your model, you want to fit it in memory. So I kind of I was limited with the size of the model that I could use to train my chatbot. So the results that I was getting was not as good as the one from the Google chatbot paper, because Google has access, obviously, to like really large machine, to lots of memory, so they can fit models that are really large and have lots of parameters. So that's mainly the number of layers, the number of cells that you have on each layer, that kind of tells how complex your chatbot or your model can be. And you have to fit the whole thing in memory. So it became limited pretty quickly on my iMac. And the other thing to note too is you can train on the CPU. So in this case, it's going to use the RAM of your computer, but this is pretty slow, like, because it does lots of matrix operations. So you want to move to the GPU as soon as possible. And my iMac is an old one. It's using it as an Nvidia card, so I could use CUDA, it's called. It's a kind of a programming language specifically for programming on a GPU. But when you switch to the GPU, you have to use the GPU virtual memory, right? So you're no longer using the RAM, so you have to use the RAM on the GPU. So that's another problem. Now I only had like 4 megs of RAM on my card. So that's where I kind of reached the limit of the model. I could not train a model larger than a bit less than 4 megs. So I bought myself actually a computer. I built a PC from scratch with two, I forgot the name of the cards, but the 1080s, I think, or 1070s GTX cards from Nvidia. So that I put them in parallel. So now I could train a total of around, I think it was 14 megs or something. So much bigger, larger models. But I have to split my model to run on 2 GPUs at the same time.
Mm-hmm. Yeah, I was at VMworld last week, or no, it was the week before last, but they had some hardware vendors that were selling hardwares that you can run your virtualization stack on, and then you could do machine learning stuff so it would connect to the GPUs. And yeah, they had like 4 or 6 essentially video cards in the back of the server, along with, all the bays for the hard drives and things like that. So that, yeah, you could do, a large amount of machine learning across the GPUs and, use the capabilities there.
Was that like Nvidia cards and whatnot?
Yeah.
Yeah,
Yep.
Because that's the problem I think they're having now in machine learning, is everything is proprietary, right? You have to code in CUDA, and this is not going to run all the other. And that's a problem too with if you were using Apple products, is now they've switched away from even the big Mac Pro. They've switched away from NVIDIA, so you can no longer use CUDA in any of the newer Apple products. So that's kind of a bum, I think.
Well, they are coming out with the external GPUs, through the Thunderbolt, so that could still open up possibilities to get the external GPU for that. But man, I think NVIDIA is I think we're in a kind of a pickle here, because you have all these Ethereum miners, like taking away all the GPUs from people who are wanting to do machine learning. It just kind of hiked up the price a bit of them. So that kind of sucks.
Yeah, definitely. There's a monopoly there, but I think because their product is much better, it seems, or it's used by lots and lots of people to do lots of cool stuff.
Yeah.
It's also kind of funny because I talked to them about sponsoring some of the shows to talk about this particular problem set, and they basically looked at me and said, "We already own that space."
Oh, okay, yeah. You can see why that's bad there.
Yeah.
Wow.
So once the computations have been done, so you've done all the trainings and stuff, and now you just have your model that gets deployed. So, fewer resources needed for the actual deployment of things. How does it go about storing and then doing progressive training?
That's another entirely kind of field of machine learning where you want to do, I think it's called online learning, where you keep improving your model over time. So you could just train your model and say that's going to be the final model, and then you deploy it and you don't update it at all. And so, as I said, this is going to require less CPU or GPU time, but it's still going to require the memory, like the memory size, because the model has to be loaded entirely in memory. But what some people do is they convert from GPU to CPU, the model. So they just train it on the GPU, but then convert the full model to a CPU, so you can, and then deploy it to the server. because it doesn't need to run as fast, and it's much cheaper to run a server with lots of RAM than a server with a large GPU. So that's the good way to go about it. And then you could do, like you said, some updates and some minor trainings on the CPU. And because it's less data, it's going to be acceptable in speed and performance. So that's an approach that I've seen a lot, is to convert it to CPU.
Yeah, so my whole idea around here is to create a Slack bot. And this Slack bot, you just add it into your channel. You use machine learning, so you're communicating with this bot, and you can tell it, like, hey, I want to spin up a whole new instance of this web environment, this web server on DigitalOcean. And then it goes out, starts researching the DigitalOcean API, learns how to just deploy with best practices to DigitalOcean. Well, you guys have a falling out with DigitalOcean. Now you say, well, hey, bot, I want to actually migrate everything over to AWS. And then the bot just, learns how to do that. I mean, I think that'd be awesome to have a bot DevOps guy.
Sure.
Do everything.
Sounds like a really cool idea. I don't know if it's doable. Well, for like the machine learning to work, you need to have lots and lots of example of. With the supervised learning, you need to have lots of labeled example, meaning like when you do this, I expect you to do that. So you would need to have scripts of DevOps doing the thing you want the bot to learn. So I don't know if it would be a good way, or you could have there's lots of research now going on with. Unsupervised or to reinforcement learning. Like you've seen all the stuff around Go, like the DevMind has won a bunch of things with Go, and now I think they're going after Dota 2, training some bots to do that. I don't know if you guys have seen this, but all of this is based on reinforcement learning, where it's a different approach. Instead of having labeled example, when you say, when I give you this input, you give me this output. Well, with reinforcement learning, what you do is you just let the bot do its own stuff, and at the end you say, oh, that was good or that was bad. So it needs to do the thing multiple times. So you could have your DevOps chat bot try to deploy a site and fail 1 million time, but maybe it's going to succeed a few thousand times. And then you just tell him that was good, and that was bad. Or you could just tell it from the status code or stuff like that. And that would be another way to do it if you don't have the example. But you can imagine how long that's going to take, right? If you want to train it 1 million times, and you have to revise the result at 2 or stuff like that. So it takes a lot longer with reinforcement learning.
Yeah, wasn't that kind of the example that the chess player robot used, where it just played out every single combination of the game, or tried to become a good chess player?
Yeah, I think so. And I think that's what it did with Go and the Dota 2. Bot 2 is it plays against itself. It plays millions and millions of games. So it plays more games than anyone around the world. So that's why it keeps getting better all the time, because it can play the games much faster than a human.
Yeah. Yeah. And then soon it'll realize it doesn't need humans.
That actually begs the question, because it seems like so many people are generating pure knowledge through this machine learning. And it seems that there should be you know how science is, where science, everybody contributes to science, it kind of, that knowledge becomes public, that public knowledge helps grow science. Same with technology, the technology helps grow technology. I would think that, and maybe there is, maybe there isn't, a place where machine learned stuff goes into this great big pile of, this is what we've learned as humanity so far through machine learning, and this is now going to become basically our global brain that we can tap into and know. Is there anything like that, or any initiative like that that's saying we want to absorb all of this machine learning data and make it into this super brain? Which, of course, down the road will end up killing us all and taking over the world.
I saw that movie, too.
I think they call that Skynet, isn't it?
I think that's Yeah, I think that's the ultimate goal, like to build an algorithm that, that's going to replace us. But I think what you mean, like it's that an algorithm that can learn already knows everything. And I think we're maybe, I don't know if we're halfway there or close, but at least I think what's exciting about machine learning is now we're starting to realize we're using an algorithm that is really similar for all those stuff that we're talking about, all the problems that are solved nowadays with machine learning, and more specifically is neural networks. All of those it's based on the same exact algorithm that is backpropagation. That's the algorithm that is used for training. So most of those are all based on that. So I think what's exciting is that we're at the point where we've found a good algorithm, one single algorithm that can learn almost anything. And we're closer to what you were talking about, like having a central mind that knows everything, is that we've found just one algorithm that can learn everything. But I think the problem we have now is if you have a model, you want to train it for a specific kind of problem, it works for that specific kind of problem. Maybe like distinguishing cats from pictures, right? But if you want to take the same model and train it to translate French to English, wow, that's going to try to do two things at once. That's going to fail miserably because it's two things that are too different from one another. And I think that's the next step, is to build a model that can do like some very different things at once. But I think the fact that and that's what excites me personally, is that I know, to me, it feels like we're really close because we have we have discovered the algorithm that can do all of this. We don't have yet discovered the way, I think, to structure it properly, maybe to train it. Maybe that's the key. We're not training it properly. So I think that's the part that is really exciting about machine learning. Maybe we should train those more like we're training kids, right? With our curriculum, like we start with simpler things, and when we expand with more and more things and whatnot. That's not how we're training models now. So there are so many things to try and to be tried by people. So that's what's cool about machine learning. But I think we're getting closer and closer to that big giant brain that you're talking about.
Cool.
So far we've talked about training the neural network, and then just building this model. Here's an idea. So I've written several hundred or thousand tests, RSpec tests for an application, and could that be used as learning data to build a automatic testing robot to test my application, so I never have to write another test?
Well, probably you have to try it. I don't know. That seems like you have some good ideas. I think you just have, you give it a try. Sometimes it works. That reminds me of some people I've seen, like they train on, I don't know if you've seen this, they train on like answers on Stack Overflow, and it became like a bot that could answer your question. You would just like ask your question and it would spit out some code. Here's how to do it. I want to open a file in C#. Boom. And it would just show you the code. That was pretty cool. And that's just based on training from the question and answers from Stack Overflow. I don't remember if it was super good, but in some cases it was decent. So
that's really cool.
Yeah, so lots of really cool stuff you can do. And all that stuff, like when you have a sequence of word, or it could be a sequence of code or images or sound, even though it's all based on the same model. It's called LSTM, long short-term memory kind of layers to add to your neural networks. And that's the same kind of model that I've used for my neural conversation model. But it's also the same kind of model that Google uses for translation. So it's all the same thing underneath. So I think that's the thing, what I'm talking about, like the algorithms are kind of converging towards one single algorithm, is that all those things that looks really different, but now we're kind of getting closer to all using the same kind of model for all those things that look different. But it's everything that is a sequence in input and a sequence and an output, you can train it with a really similar model. But we're not there yet, is that you have to try it, and then usually you have to spend a lot of time. That's what machine learning scientists or whatever you call them, researchers do, is you tweak the knobs or the parameters of those and try, and nobody knows what it's going to do, but sometimes you just find the answer and you don't stop touching the knobs and you call it a day.
This episode is sponsored by Airbrake. I don't know about you, but week in and week out, I spend hours debugging my code when I could be working on building new stuff. Then I started using Airbrake.io. our latest sponsor, and the time I spent debugging was cut in half. Airbrake alerts you to errors in your software, then helps you diagnose and fix them. That means no more wasted time searching log files and more time writing and shipping great code. Airbrake supports .NET and all major programming languages. Sign up at getairbrake.com/rogues for a free 30-day trial and the chance to win a $500 Amazon gift card at the end of the month. It's a completely free trial and you'll be shocked at how much time it saves you. Again, that's getairbrake.com/rogues. So one thing that I'm wondering about with a lot of this, we're talking a lot about how to do machine learning and some of the principles behind it. But let's say that I decide, you know what, I want to build a machine learning system that will, take in a large data set. Maybe I take in some of the government data out there, right? So maybe it's weather data from NOAA or crime data from across the U.S. or, maybe there's some political polling data that's out there that I'm curious about or, other things that, either because of my political leanings or because I want to know who's right. And I'm kind of agnostic on whatever point, it's like, okay, how do I figure this out? So I'm going to go solve this problem with machine learning, but I don't actually know anything about machine learning. So where do I start? Like, where do I start, pulling this stuff together and plugging it in so that I start seeing results that are going to help me figure this stuff out?
So you mean, how do you start for a typical developer?
Yeah.
How can you start? Well, I can talk a little bit about how I did it. So as I said, I tried with the Coursera course from Andrew Nung. I think I get his name right. But that didn't work. And what motivated me really is to have found a project that I really, really wanted to do, which was the Google chatbot paper. So I think that the first step is to find a project that you really want to do. And after that, what I did is I can paste the link later, but I found a site to browse the research papers. So that's going to sound really daunting at first, but just bear with me with a moment. So what I did is I started reading some simple papers that were the more popular in the fields. And at the beginning would really go over my head with just, I would understand some of the words, right, in the paper. So I can understand maybe a third of this. And it was really... not really difficult, but I kept going and read more and more papers. And as times went by, I could say, I've learned this from this other paper and start to put things together. And after a few months, I would say I started to understand more and more what the papers were about. Because once again, machine learning is a really evolving field really rapidly. So you have to kind of keep up to date with what's happening in the research paper. But it's true also for other fields. I did the same thing when I wanted to learn about compilers and parsers, that I read research papers, but those were much older than the one about machine learning. So I kept reading and reading about those, and sometimes the papers do come with the code, so you can inspect how they implemented this and what frameworks they use, and I kind of tried to mimic a bit what I would see in the papers, and I copied a lot of the code that I would see from papers about translation. Right, because it was really similar to my own problem. Chatbots are really similar in structure to how the neural translation is done. So I would just copy the code and mimic what they were doing. And from there, I kept reading more papers and eventually had my own Google chatbot paper implementation that yielded some really decent results. So I think that's the way to do it. Is you have to kind of accept the fact that it's not something that you can learn quickly. It took me a year just to get over that, to start understanding the research paper enough to implement some parts of them. Not everything. I don't understand everything when I read a research paper on machine learning, but I do understand some of the parts enough to implement a simple version of what's described in a paper. But I'm not a machine learning expert, but I think I went from knowing zero or almost zero about machine learning in a year to being able to implement some simple models. And that was enough, I think, to implementing the neural convo was the first implementation, open source implementation to implement that model from the Google paper.
One other thing that I'm curious about with this is, you implemented the neural convo, and you mentioned that earlier, and we'll put a link to it in the show notes. But how much of that did you have to build from scratch? Because I know that a lot of people, as they get into machine learning, they go with something like Python or some of these other languages that have large scientific or mathematic libraries. And I keep hearing about Ruby's deficiencies in that area. So is it deficient or... Yeah.
Yes. Well, Ruby is deficient. It's not really about the language implementation. That has very little to do with for what we're concerned. So machine learning is really matrix computation heavy. So you need to have a good scientific library like NumPy that in Python. That's why Python is so popular in machine learning, is because they have NumPy that has existed for so long, has been battle tested, and it's really fast. It has a bunch of features. And I think it can run on GPU too. So I'm not sure. I haven't used it that much. So that's one of the options, is to use Python with NumPy. So that's the important part, to have a numerical library. And also there's Torch, which is actually a library implemented in C. So now they have a PyTorch that you can use in Python. But I've used the one that is based on Lua. It's called just Torch. That's the one I've used for my project. And it's mainly like very similar to NumPy, but it's in Lua and LuaJIT, which is actually faster than Python on most cases. So it's I think it's a really good language that looks a lot. If you've never used it, it's really similar to JavaScript in many ways, but it's actually also much simpler and removes some of the parts of the JavaScript that are quirky or weird. So it's a really nice language.
So just go do it.
So I would use... Yeah, well, so that's what I did. I used Torch, but when I started working on that project, the base of the model, which is called sequence to sequence, it's kind of the type of model that you have to build, was not, I would say, mainstream much. So like the big libraries like TensorFlow and Torch didn't have any built-in ways to do that, or where they were not good enough with what I wanted to do. There were some example in Torch, so that I started coding and copying some of the parts that I would see from Torch examples, and some of the papers that I would read, and I would go from there. And also, eventually, once I got some decent results, so they were not exceptional, but I just got a chatbot that could respond to hi and what's your age and what's the color of the sky. Was not super impressive. As soon as you would go out from ask other questions, it would just babble something that made no sense. So I published it on GitHub, and some people that knew more about machine learning started contributing. And that's where things started improving more quickly. So it was with the help of open source contributors too. And yeah.
I'd love you to talk about, if you don't mind, the Great Code Club. I was looking at this, and I'm pretty amazed. You definitely are an entrepreneur with an eye towards teaching other people, which I think is great. What was behind the motivation behind that, and what did you kind of take from that?
Sure. Well, I think it started with so as Chuck mentioned. So I've been teaching online classes for some time now, maybe 6-7 years. And I think that's all I did. Right? I kind of stopped coding on interesting projects or any stuff that was not directly related to my courses, because, well, as with everybody, I had to make a living and pay the bills, and that's how I did it with the courses. But after some time, kind of got bored with just doing that, just redoing the same classes. So I came up with this idea of the Great Code Club, which was for me personally a way to force myself to come up with a new project each month, and at the same time would help people and would teach people how to do it. So it was over the course of a year. I think it was 2 years ago or something like that. And each month I would just start the month with choose a project, learn everything that I had to code this project and rebuild it from scratch, and then record the videos, the voiceover, and build a few exercises around that. And I would publish it on the Great Code Club, which started initially with just a forum. It was a Discuss forum. Mm-hmm. Is it called Discuss? I forgot. But so I installed this on some server. Discourse, yeah, exactly. Thanks. And then I would just have people pay a monthly fee, a subscription, and each time I would promise them that each month I would publish something. It was actually coded entirely in JavaScript, so I promised them that I would deliver a new course each month. And the first one was 2D retro gaming, and for the second one I think was re-implementing a language which I had some experience with. And I went like this, and eventually, and built everything that interested me, and I thought that might interest others. We built a virtual machine, some parts of a database with an indexer. Cool project, I think, was building a raycaster, a 3D raycaster, like Wolfenstein 3D and Doom. Out they were the first version were coded. We coded all of this from scratch in the browser. It was a really cool project. We built a virtual machine with a debugger and back-end and front-end frameworks. So that helped me also learn about stuff like Backbone, Ember, Angular, and whatnot when building a front-end framework. A real-time engine to push updates to the browser like Socket.io. And we finished with the final project in December was to rebuild a neural network, which I knew that was my first implementation ever of a neural network, and I knew nothing about this at the time. So I had a book at my own, so I started just flipping through the page, and I learned really quickly, but I learned only on the surface how to build a neural network. So I did manage to build a course around that on the final month of the core of the club, but my understanding of neural networks, machine learning at that time were really superficial. So we did manage to build a neural network that could predict some really basic stuff in the Great Code Club, but I think might not be the best course to go delve into the details of machine learning and really master it. It's really more superficial stuff. So that was the whole plan, the whole story of the Great Code Club. It was mostly for me to force because I think it's really tough when you're in that spot. It's been a long time that you've coded and you want to get out of it. I tried several things. Like I wanted to build a SaaS or any sort of recurring revenue. I was kind of tired of teaching people. And I tried several things and failed and kept failing. And I felt really stuck and started to feel depressed. So that's the way that I found to get out of that hole and force myself to learn new things again and have fun coding again, because I kind of lost my passion a little bit while teaching all the time.
I love the blog post that you talk about the lessons that you've learned. Never start with nothing. Inspiration is perishable. There's no such thing as a failed project, and lowering your expectations. It's awesome.
Yes, thank you. So that's a blog post that I wrote about when I was starting with the Great Code Club, and it's when I discussed about my how I learned actually. So the machine learning is the approach that I've used for learning this is the same approach that I've used for learning about parsers and compiler. Is that quite some years ago? I think it was 8 years ago. I don't know if you were around in Ruby at that time, but there was lots and lots of competition with Rubinius, like MR, where it was starting to get more faster, and also there was JRuby. Like there was so much competition. Everybody was trying to build the fastest Ruby implementation at the time. And I remember that was super excited. I was so exciting during that time because everybody was just coding furiously, and everybody would show numbers and say, hey, I'm a bit faster than this implementation and that. And everybody would have a friendly fight. And I think that's the part that is really exciting, is everybody's motivated to give their best and just to be better than everybody. But at the end, everybody's benefiting from all those advances. So that really drove me to learn about this stuff. So I spent same approach that I discussed earlier to learn about this stuff. And my objective was to build the smallest Ruby implementation. And it was I finally based my design on the virtual machine of Lua, which is to me one of the most amazing things that I've seen in software. The design of the bytecode in the virtual machine of Lua is incredible. It's so simple, but yet so effective. So I think it's a work of art. If you want to ever dive into something that is worth diving into, I think the bytecode of the Lua virtual machine is pretty incredible.
Lua is also the officially backed sponsor of World of Warcraft.
Oh, really?
Oh, really?
Okay, I didn't know that.
No, I'm not saying that, but if you're in a modified World of Warcraft, that's actually the language that they use. You bring up Rubinius. You bring up Rubinius, and one of the funny things that happened. So this was back in, this must have been 5 years ago. I was at a Mountain West Ruby conference in Salt Lake City. And Evan Phoenix was up there talking about Rubinius, and he never once explained what Rubinius was. And I've never heard of it before. Okay. So I'm sitting there, and about 10 minutes in, I'm such a moron. I raised my hand, interrupt the talk, and I said, "What are you talking about?" So He gave me a really crusty look and then just continued.
Well, even I know. Well, to his credit, I think it was really deep. He was coding lots of the internals of Rubinius and done some pretty amazing work there. So I think sometimes when you're too deep into some coding, you kind of lose perspective. So maybe that's what happened there. But even Phoenix, he helped me a lot with my Tiny RB was the name of my Ruby virtual machine. So I stumbled through a lot of problems building that VM. It was my first one, but he helped me a lot and explained like some of the ways how he would solve some problems. So a lot of the reason why my implementation is really fast is because mostly of even Phoenix. Yeah.
That's cool. So during this time when you're choosing a project every month, did you find, how did you know what to work on, or how do you know what side projects that you want to work on?
I think I've written this in the notes, but I have 4 steps that I go over when choosing a project, when choosing a side project. And I've always followed those 4 steps, and that has helped me to complete the project. So either complete it enough to my satisfaction or to a level at least that I can publish. So that's the 4 criterion that I've used all the time to choose a project for the Great Code Club, but also for me personally. Is first, I always choose a project that doesn't have any dependencies or very little dependencies, because that's a big problem that I see a lot of people do. Is the people say, I'm going to start a this type of project, and I'm going to base it because I want to learn Ember, I want to learn Angular, and then I want to learn this too. And it ends up being a large mud ball of a bunch of technologies, and you spend a few months, and the only thing you've done of those few months is stick together 2 technologies. So that's perfectly fine. Is your whole goal is just to learn the technology. But if you want to build something and have something to show for it at the end, that's not a good way to go for it. So my first criteria is always to choose a project that has as little dependency as possible. So all the 12 projects that I've done in the Great Code Club have close to 0 dependency. So we rebuild everything from scratch. So that can look a little bit stupid in retro when you look back at it, but usually you can find some ways around, or you can use, I'm not saying I didn't use any libraries, but sometimes there was just one, but then no way I was going to use like 10 or 20 dependencies on a project or something like that. But because I think that's not fun, and you don't learn much, and you don't, usually you're not going to end up with something at the end. So it was my first one. The second one is I usually start do a project that I copy. I copy from somebody else. I don't copy the code, but I copy the idea, or I copy the structure, or I copy what they do. Or I borrow would be maybe a better terms, but I prefer to say I just copy the idea, what they have, and how they've done it, and try to do a little bit better. So the third one is I try to keep it small. I really force myself to keep the number of lines of code small. So that has really helped me in the Great Code Club. Is usually I would set the level to 300 lines of code and not more. So it would force me to say, I'm going to cut that feature because that's going to be too much. I would just try, if I would like build a database engine like we did in the Great Code Club, I would say, maybe writing to file, it's going to be too much work. So what I did is I kept the database in memory and just focused on rebuilding a data structure, binary tree for the indexer. So that's all we focused on about, because if we wanted to build a real database engine, it would end up being too big. So that's my third one. And the final one is I usually try, maybe not for the Great Code Club, but for my personal project, is I would try to focus on just one feature and make it like the better X than on this type of feature. So let me give you an example. For example, with my project 10, what I did is initially I told myself I'm going to build a faster mongrel clone from scratch in less than 500 lines of code. So the key feature, the unique feature was that's going to be faster and also more stable than mongrel. So I would copy mongrel. So that was the second criterion. And also I would do it from scratch, so with little to no dependencies. And I would force myself to keep it under 500 lines of code. So I would cut features and stuff like that so that I could maintain it, and it would still be fun to work on it because I could easily refactor it. And I did So I took this approach with all the projects in a Great Code Club, all my projects in machine learning, and that's usually that has helped me a lot in completing the project and shipping them. So that's a really important thing, is you want to ship them and put them on GitHub at least, and then promote it. And that's useful for so many things, right?
Perfect.
Awesome. All right. Well, I need to get to picks. I've been doing Angular Dev Summit this week, which has been super. We've had 660 people sign up for it. I'm assuming that Ruby Dev Summit will probably have a similar turnout or better. But yeah, let's go ahead and do some picks. This episode is sponsored by Hired.com. Are you searching for a new job? That can be stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through the interview process just to find out at the very end that the salary, offer, or company culture doesn't match what you're looking for. Hired is the world's most intelligent talent matching platform for full-time and contract opportunities in engineering, development, design, product management, data science, sales, and marketing. We make your job search faster, focused, and stress-free. Instead of endlessly applying to companies and hoping for the best, Hired puts you in control of when and how you connect with compelling new opportunities. After completing one simple application, top employers apply to hire you, and on Hired you receive personal interview requests and upfront salary information so you can make informed decisions about what opportunities to pursue over a condensed timeline. Hired offers access to more than 4,000 innovative employers, including big brand names like Facebook and smaller emerging startups. The size and type of company you want to connect with is totally up to you. And we help you find new opportunities in 17 major cities in North America, Europe, Asia, and Australia. Open to relocation? Let them know. Your privacy and autonomy in your job search is of utmost importance. And if you sign up today using the show's link, that's hired.com/rubyrogues, you can get double the normal hiring bonus. That's $600 instead of $300. So go check them out at hired.com/rubyrogues. Eric, do you have some picks for us?
I got one. This one is actually right in line with what we're talking about. You guys know about code. Well, I'll talk about Code Sponsor as well. Code Sponsor is one of my picks, of course. We are helping sustain open source projects through ad-based funding. We now have, I think, almost 300 repositories, almost 200 developers involved. We've got a nice flow of money coming through that basically, if you want to get funding for your open source project, for example, Thin or something like that, just go to Code Sponsor and you can add your repo super easy and you just start making money. The other thing that, and the reason I brought that up is because that led me, we find these sponsors that are interested in communicating, getting their message out to developers. And one of our sponsors, one of our first sponsors is CoreLogics. And what they do is they actually use machine learning in your logs to be able to determine, they have something called log regression, and it uses machine learning to actually say, look, we know there's a lot of noise in your logs. We're going to use machine learning to actually just take out the parts that we think are the most important. We're going to display that for you and give you a lot more tools around it. So corelogics.com, I think they're a great company. I love them because they sponsor Code Sponsor and they sponsor open source developers, but that's my pick.
Awesome. Dave, what are your picks?
All right. So my first pick is the best mouse for programming, or at least that's what this review says. So I picked up one of these mices. It's a Logitech MX Master 2S, and it's been actually really nice. Took me a day to get used to, but it's been a great mouse because my other one died on me, which never happened before. But so that's my first pick. My second pick, just with the Hurricane Irma and all that junk that's been happening on the southeast United States, we lost power several times last night, just as, we're in Atlanta, so we definitely didn't get anywhere near the storm that Florida did, but we still lost power, and I was able to continue working and not have any downtime, for like 20 minutes that we were out, thanks to UPSs. And that's just an uninterruptible power supply. And not only are they good for surges, where you have a spike in electricity, but they're also really good for protecting your electronics for brownouts, which is where you have a dip in electricity. So definitely anything that you care about that's electronic, throw it behind a UPS. Nice.
So I'm going to jump in here with a few picks. First one is, I just want to shout out again about Ruby Dev Summit. Definitely go check it out. It's free if you want to just watch, and it's you have to pay to get access to the video recordings and things like that. But I'm also giving half the money to the speakers, so it's also kind of a way to say thank you to them for putting the time in. And then one other thing that I'm going to pick, I had the opportunity, we're going to put it that way, of finding out how water gets into my house. And that's because the water main on my house cracked and was leaking water all over the place. In fact, I have a big hole that we dug out that then caved in. So we wound up bypassing it. So the Home Depot is where we got most of our parts. They had pretty much everything we needed. So I'm going to pick them. And then we also rented a mini excavator. I didn't know they had these things, but it's like it's got the big bucket on the front and it scoops dirt. And so I'm going to pick mini excavators just because I think they're cool. And the last thing I'm going to pick, we did talk about machine learning and data science, and there's a terrific podcast out there by Kyle, I forget his last name. Anyway, it's called Data Skeptic, and it's really enjoyable. So every other week he interviews somebody, and then on the other every other week he sits down with his wife and actually explains to her data science concepts. So anyway, it's pretty good, and I really enjoy it. And I met Kyle at some of the Microsoft events that Microsoft has had me come out to. They've also had him come out. So anyway, great stuff. Mark, what are your picks?
I have two. The first one is one of my courses, actually a free one. So if you enjoy rebuilding stuff from scratch, it's called Rebuilding a Ruby Web Server from Scratch. I go from building 3 types of server. We go from the parser to rack, what is rack and how to, and then we implement 3 types of concurrency mechanism. One, the same as Tin, an evented one, the same as Unicorn, a pre-fork server, and the same as a Puma, which is a thread-based server. So if you want to know about the difference of those 3 types of concurrency, how rack plays in all of this, and how the web server is built, you can check it out. I'm going to provide the link. And also, I talked a little bit earlier that how I learned machine learning and learn about compilers is by reading a research paper. Well, a good site to browse research paper is called Archive. What are the special way to write it? So I'm going to provide the link, -sanity.com. It's a really great site with some aggregation of some of the best papers. It can do some recommendation based on the ones you like, sort them by the categories and whatnot. So that's a good way to browse a research paper and start diving into some of them.
All right. If people want to follow you on Twitter or GitHub, see what you're working on these days, anything like that, maybe have a blog that people should read, where do they go?
It's going to be mostly on Twitter, I guess. I'm not super public I don't have much time now to do some public stuff, but it's going to be mostly on Twitter. So twitter.com/MA Cournoyer. So it's my last name, no space whatsoever, just MA and my last name. That's it. And the same username on GitHub too, if you want to follow when I'm coding. That's it.
All right. Sounds good. Well, we'll go ahead and wrap this one up, and we will catch everyone next week.
All right. Talk to y'all later.
Thank you.
Take care.
Bye. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.